Okay, so complex number is a number in the form of a plus bi, where a and b are real numbers and I is an imaginary number. We are going to start with addition and subtraction, okay? So Bradley, can you read one step in that box? It says addition and subtraction.
Combine like terms.
Yep, that's all we got to do when you add and subtract, y'all. So examples 1 to 4. The quantity of, here we go, example 1. Quantity of 8 plus 7i plus the quantity of negative 12 plus 11i. We have an addition problem. So when we have an addition problem, students, we don't have to worry about distributing anything because we can just write them as is without changing any sign. How come, guys, how come when we're adding, we don't have to change the signs at all? Technically, what numbers are in front of these quantities? 1, yeah. So if there's number 1s here and we just, what's happened to 1 times anything? It's the same. So that's when it's an addition, we don't have to change anything. Now, we're going to write the 8. A plus and a minus, is that the same thing as just a minus? Yep, we're going to write the numbers without the i's in the front. And then we're going to write the numbers with the i's in the back. 8 take away 12 is negative 4 plus 18i. Box it up. Just like that. Now, number 2 is an addition or subtraction? Yeah, okay, so now because it is subtracting, what should we do with the second quantity? We change the signs, right? Because we need to distribute that negative sign throughout. So this is the first one is exactly the same. And in negative 1 times positive 3 is negative 3. Negative 1 times positive 2i is a negative 2i. Write all of the non-i's together and all of the i's together. Okay, put all like terms together. Negative 3 and negative 7 would give us negative 10. 4i take away 2i would give us 2i, and box it up. Okay. Okay, I want you guys to try out examples 3 and 4 on your own, and then once you're done, I want you guys to check your answer together. Oh, mine just got disappeared. Try out 3 and 4 on your own. I'll give you guys 3 minutes. Once you're done, please compare your answer with the people that's sitting next to you. I'm trying to find my paper still. It got moved. There you go. You guys should already have this in your notes packet, okay? Try it out. If you're done, can you please share your answer verbally to the people that are sitting currently next to you? Go. All right, Courtney, what did you get for final answer, Courtney, of number 3?
2 plus negative 11i.
Negative 11i. Okay, so Courtney said 2 plus negative 11i, or is that okay to write 2 minus 11i? Is that okay as well? Okay, so again, it's an addition, students. Okay, so I'm just going to go straight up, writing like this. Is that okay to write like that when I want to combine like terms? Yeah, totally. So if you choose to write 2 minus 11i, that is also correct. Either way, we will accept. Okay. All right. Sebi, what did you get for 4? Final answer.
-1 plus 5i.
-1 plus 5i. Let's check it really quickly. And again, the first quantity, students, we don't need to do very much. But the second quantity, what should we write down? -5 plus 2i, okay? So 4 and a -5, that is definitely -1. Good job. 3i and a 2i, that is definitely 5i. Good job. Perfect answer. All right. Next, we are about to multiply these complex numbers. So here are the steps, okay? Okay, step number 1, you will either distribute or you FOIL. You FOIL when you have like a binomial times a binomial or a binomial times a trinomial. You distribute when you have a monomial times a binomial or a monomial times a polynomial. Step number 2, once you guys are done distributing or FOILing, then you would need to simplify the power of i's, okay? The power of I. And last one, combine like terms, aka find the final answer. So example 5 is pretty straight up. Distribute. 3 times 2 is 6. 3 times 4i is 12i. Box it up because it's in a plus bi. Pretty easy. Okay. 6. 2i times 3 is 6i. 2i times 5i is 10i squared. Can I leave my answer like that? No. What is I squared? Yep. So this is 10 times -1. What's 10 times -1? -10. So we want to write it a plus bi. So -10 plus, how many i's? 6. Okay. So a plus bi. The i's go second. Devin, am I going too fast, hon? Okay. Yeah, if I'm going too fast, you let me know. All right. I'm going to move up. Number 8. No, it's not it? 7. Oh, I'm sorry. I missed that right side. I lied. 7. FOIL. Here we go. 8 times 2 is 16. 8 times -3i is -24i. 5i times 10 is 10. I'm sorry, I just gave the answer. Yeah, I do that a lot. 5i times 2 is 10i. 5i times -3i is -15i squared. Box it up, call it a day, take a nap. No. Combine these for me. What's in the middle? Positive and -14. -14i, right? Minus 15. I squared will be changed to -1. Well, what is -15 times a -1? Positive what? Positive 15. Would you guys agree? And would you agree that I'm going to need to combine it with the 16 in the front? So I'm going to move it to the front because we want to write it a plus bi. So final answer is 31 minus 14i. Box it up. All right, let's go down. Eight. What should we do with 8? Not exponent to each term. We need to write it out. How many times, students? 2. And what? FOIL. Yep. So -5 times -5 is 25. -5 times 6i is In the middle is also negative 30i. 6i times 6i, 36i squared. Now, some of you are getting better and better with this. If you see 36i squared, can you straight up write negative 36? Yeah, if you're there, do it, okay? So we know that this is going to be 36 times negative 1, right, students? Okay, so I'm going to put that together with the 25. So we know that's going to be 25, take away 36. In the middle, what should we get? Negative 60. All right, is that okay? So far, so good? Final answer. What should we get? Positive and negative 11. Negative 11 minus 60i. Okay, I'm going to give you a minute head start on number 9. When you have an answer, box it up. If you have an answer to 9, share your friend and move on to 10. Once you have the answer to 9, I want you to verbally share with your friends before moving on to 10, please. Grace, whenever you're ready, hon, can you give me the final answer to 9? What's up, Cam?
I mentioned like numbers like 8 through 13.
Say that one more time.
I don't have like 8 through 13.
I thought I already gave you. Oh, yeah. Dang it. All right. Can you just copy it down then? On maybe just cross that out and just. Oh, yeah. How about this? Copy it out. How about in the back of that? Oh, sorry. That packet's a mess. Yeah, if you guys know what 9 and everyone in your group agrees with the answer, move on to 10. Compare answer to 10. Everyone agrees to 10, move on to 11, and so on, okay? So for that one, Grace, you want to do 5 times 400, which is what? Remember, 1 of 4, is 20. Yep. And then 5 times negative 100 is what? 5 what? And then in the middle, 2i times 400. Yep. And then 2i times a negative I is going to give us what? To what? Perfect. Not in the notes, hon. You have to wait. Okay. Then we're going to have 20. Okay. Negative 5i plus 8i is?
That's 3i.
And then I squared, we would change that to what, hon?
It would be negative 1.
Good. And then negative 1 times a negative 2 would give us?
Positive 2.
Yep. So final answer is?
22 plus 3i.
22 plus 3i. Hey, someone confirm number 9 for me?
22 plus 3i.
22 plus 3i? Yes, no, maybe? All right. Make sure we check all of the signs, okay? Double check our basic math. If you didn't get it right, correct it. It's okay. Okay. Number 10, okay? I know not all of us are there, but I'm going to see if you're there, you can tell me. Ian, final answer to number 10 if you have it. 25. Who agrees if you got it? All right, I'm going to work it out to see if it's true. 3 times 3 is 9. 3 times 4i is 12i. In the middle? Negative what in the middle? 12i. All right. Negative 4i times positive 4i is negative 16i squared. Can I change it straight up to positive 16? Yes. So you can write negative 16i squared, students. Or if you're super comfortable, you can go, oh, you know what? I know I squared is negative 1. Negative 1 times negative 16 is positive 16. All right. Then, combine like term. 9 and 16 will give us 25. But what's happening to the i's? They disappear. Final answer. Good. Okay. Same answer. All right. Go and do 11, 12, and 13. Work it out. Box up your final answers. Guys, compare. Box your answer if you're done. Did I mess up in your packet? Okay, Kyle, final answer to number 11, honey, if you have it. 11, Kyle, final answer. What did you get? 13. Raise your hand if you agree. Okay, if you didn't agree, here we go. Negative 3 times negative 3, students, that's going to be positive 3. I'm sorry, not positive. Ooh, positive 9. Negative 3 times 2i is negative 6i. In the middle, a negative times a negative, students, that would be a positive 6i. Negative 2i times positive 2i, that's negative 4i squared, which we can change it to immediately what? 4, right? 9 plus 4 is 13. Terms in the middle cancel. Okay. 12. Raise your hand, you have an answer for 12. Sarah? 50. Okay, let's see. 7 times 7 is 49. 7 times negative I is negative 7i. I times 7 is positive 7i. I times negative I is negative I squared, which we know it's a negative of a negative 1, right? Which is straight up positive 1. Combine those. That's 50. Cancel, cancel. Perfect. Last one. Let's see if we can. Okay, so if you, yep, Jacob, what did you get? 100 even. All right. 8 times 8 is 64. 8 times negative 6i is negative 48i. In the middle? Positive 48i. Okay. At the end, negative 36i squared, which is straight up 36. Cancel, cancel. Those two. Yep. Perfect. So now, this question says, what do you notice about the last few examples, such as, example, I want you to look at example 10 for me. Example 13, 12, and 11. Look at those examples. What's happening to the answers? Sam? Yeah, those last 4 examples, all of your answers are just nice real numbers. Now, I want you to analyze the questions themselves. What's happening to the questions? What's happening to the questions?
Each binomial has the same numbers.
Except?
The positives and the negatives.
Right. Each binomial, on all four of them, they are identical except what in the middle? Right? The signs, the operation in the middle. Okay? So when the numbers, when the binomials are identical except the operation in the middle are, that's the only thing that's different, guys, or the opposite, we have a term for it. The term for it is called conjugate pair. Okay? Those are all, students, conjugate pairs. So definition is conjugate pair are two pairs of binomials. Binomial means how many terms? Two. Okay? With identical terms, but sharing the opposite operations in the middle, just like what Sam said. Okay? So binomial pair means two pairs. Okay. Everything's the same, except the signs in the middle are different. All right, Ethan, whenever you're ready, can you read the instruction for example 14 to 16 for us, please? Ethan, just read the instruction then.
Find the conjugate of each and multiply the conjugate pairs.
Perfect. Find the conjugate of each. Remember, we're doing two things, so we should have two boxes. So, box number 1, find the conjugate of 2 plus 9i. Dylan, what? Oh, no, Dylan's not here. Dylan's not here. Jasmine, what is the conjugate for 2 plus 9i? Where's Jasmine? Okay, what is it, huh? I can't hear you, hon. What is the conjugate for 2 plus 9i? Talk to your team, Jasmine, if you need help. What? Sorry, I can't hear. Not 2 and 9. Remember, it has to be a binomial. And by definition, Jasmine, conjugate pairs are two binomials. Everything should be exactly the same, team, except what, team? Okay. So look at examples 10, 11, 12, and 13. Those two binomials are all conjugate pairs. Okay? So, Jasmine, everything should be the same except the sign in the middle. So number 14, Jasmine, one more time. What would be the conjugate for 2 plus 9i? Everything should be the same except the sign in the middle. So what should we write down? Okay. He said it. I want you to say it. 2 minus 9i. Box that up. Now, students, we will also need to multiply these. So don't forget. Okay, it says write the conjugate and multiply. So 2 plus 9i times 2 minus 9i. Now, we know for sure that these are conjugate, students. So here's, if we look back at our examples 10, 11, 12, and 14, I'm going to point out something, which I know you guys already know. Can you guys see that all the middle terms all cancel? All of them, all conjugate pairs. So if you really just pay attention, we only need to multiply the first two terms and the last two terms. That's it. Because the O and the I are cancel. So that's what we are going to do if we have conjugate pairs. We will only multiply the first two. Okay? So what's 2 times 2? 4. And the last two. What's 9i times a negative 9i? Negative 81i squared, which I know you guys said it. You guys said what? 81. So what's 4 plus 81? That's right. So can you see that if it's conjugate pair, it's a lot easier to multiply? All right, Bradley, what is the conjugate for 7 minus 5i, bud?
7 plus 5i.
Yes, sir. 7 plus 5i. Multiply them together. Okay. So Bradley, when you multiply, final answer. What did you get?
My final answer?
Yeah.
74.
Bradley said 74. Let me verify. Again, I'm just going to multiply the first two. 7 times 7 is 49. And the last two. Negative 5i times a positive 5i is negative 25i squared. But can I change it straight up to positive 25? Yes. Do you guys agree with Bradley on his answer? Yes. Perfect. All right. Conjugate pair for this one is, someone said, yeah, what is it? Yep, keep the negative. Negative 1 minus 6i. Perfect. Then we're going to multiply them together. Negative 1 plus 6i times negative 1 minus, negative 1 minus 6i. Okay. Negative 1 times negative 1 is going to be positive 1. 6i times a negative 6i is a negative 36i squared, which make it into a positive 36. Final answer, 37. All right. We'll leave that up. Okay. Tonight, we are done early, so go ahead and take out your 1.4 worksheet. Work on it now as I